Hello friends, in this lesson we will discuss the numericals on Otto cycle under the course name Basics of ISO Engine. But before proceeding to this lesson, I would request you all to go through lesson 1 and 2 because lesson 1 and 2 are linked with this particular lesson. Understand those lessons very clearly, then only you can solve the numericals on Otto cycle. But before proceeding further, I would like to introduce myself. My name is Harshit Agarwal, mechanical engineer, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Services examination. I have got the offer letter from most of the Maharatna and Navratna companies. I have cleared GATE examination. Regarding course fee, there is no course fee as such, but you can always contribute whatever you feel like. You can also follow me on the specified link. To start with numerical 1, the first numerical says an ideal air standard cycle has a compression ratio of 8.5 and the value of gamma is 1.4. Find the efficiency. The compression ratio is given in the numerical which is 8.5 and the value of gamma is given at 1.4. We have to find the efficiency. We have already derived the efficiency of Otto cycle in my previous lesson. The efficiency of Otto cycle is 1 minus 1 upon r raised to power gamma minus 1, where r is the compression ratio and the value of gamma is given as 1.4. So 1 minus 1 upon 8.5 raised to power 1.4 minus 1, which is equal to 0.575. So the efficiency of Otto cycle is 57.5%. Now here comes the numerical 2. The numerical 2 says for an engine operating on air standard Otto cycle, the clearance volume is 10% of the swept volume. I have already explained you what is the clearance volume. I have already explained you what is the swept volume. The clearance volume is 10% of the swept volume, which is Vc is equal to 0.1 times Vs. We have to find the efficiency and the value of gamma you can take it as 1.4. So Vc is equal to 0.1 times Vs. Vec upon Vs is equal to 0.1. R is equal to 1 plus Vc Vs upon Vc, because R is what? Vc plus Vs upon Vc. We have already discussed this in our previous lesson. So the value of R comes out to be 11. We have to find the efficiency of Otto cycle. So the efficiency of Otto cycle is 1 minus 1 upon R raised to power gamma minus 1. R, the value of R is 11. Right. So 1 minus 1 upon 11 raised to power 1.4 minus 1. The efficiency of Otto cycle comes out to be 61.6%. Here comes the third numerical. In an engine operating on ideal Otto cycle, the compression ratio is 5.5. The compression ratio 5.5 is given in the question, and one more thing is also given in the question, which is work output per cycle is 23.625 into 10 raised to power 5 Vc. The work output per cycle is 23.625 into 10 raised to power 5 Vc, where Vc is what? Clearance volume in meter cube. What we have to find? We have to find the mean effective pressure. Keep in mind, mean effective pressure is net work done divided by swept volume. So first of all we have to find Vs. See, the work output is given in terms of Vc, 23.625 into 10 raised to power Vc, and also compression ratio is given as 5.5. We can write compression ratio R equal to 1 plus Vs upon Vc. Compression ratio R 5.5. 5.5 is equal to 1 plus Vs upon Vc. So Vs is equal to 4.5 times Vc. Effective pressure is net work done upon swept volume. Net work done is 23.625 into 10 raised to power 5 Vc, and Vs is 4.5 times Vc. Cancel out Vc. The mean effective pressure would be 5.25 bar. Again, I am explaining this numerical. The compression ratio R is equal to 5.5, which is 1 plus Vs upon Vc. We can write Vs in terms of Vc, which is 4.5 times Vc. Mean effective pressure is net work done upon swept volume. Net work done is 23.625 into 10 raised to power 5 Vc, and Vs is 4.5 times Vc, which we have already seen here. So the mean effective pressure would be 5.25 bar. Here comes the numerical fourth. Numerical fourth says an engine working on air standard Otto cycle has a cylinder diameter, that is bore diameter is given as 10 centimeter and the stroke length is given as 15 centimeter. Bore diameter 10 centimeter, stroke length 15 centimeter. Clearance volume is given as 196.3 centimeter cube, which is Vc is equal to 196.3 centimeter cube, and heat supply is 1800 kilojoule per kg. Clearance volume is given as 196.3 centimeter cube and heat supply is given as 1800 kilojoule per kg. Find the work output. We have to find the net work output. We can write swept volume as pi by 4 d square into L. D is bore diameter, which is 0.1 meter. L is stroke length, which is 0.15. So compression ratio R is equal to 1 plus Vs upon Vc. Vs is pi by 4 d square L and Vc is given as 196.3 meter cube, right? So the value of compression ratio will come out to be 7. We have to find the efficiency of Otto cycle is 1 minus 1 upon r raised to power gamma minus 1. The value of r is 7 and gamma minus 1 1.4 minus 1, so the efficiency of Otto cycle is 0.5408. And we also know that efficiency of Otto cycle is net work done upon heat supplied, and efficiency of Otto cycle is 0.5408. Net work done, we have to find the net work done, and heat supply is given as 1800. Efficiency is either 1 minus 1 upon r raised to power gamma minus 1, and the general formula of the efficiency is net work done upon heat supplied. We have to find the net work done, and heat supplied is given in the question. So 0.5408 into 1800 is net work done. So the net work done in this is 973 kilojoule per kg. So these are the basic 4 numericals of Otto cycle. You can just go through them, you can just solve them on your own. If you want, I'll be coming up with the more difficult numericals. You can have your queries in the comment section. I will surely reply to those queries. Thanks a lot from my side. This is Harshit Agarwal.